Hi, today we're going to talk about Punnett squares with two traits. Figuring probability for crosses with two traits can be done with really big Punnett squares, or it can be done with the same easy small Punnett squares that you already know how to do and just a little bit of very easy math. You can even use a calculator. So we're going to talk about the second way today, but I will put a link to a video that shows you how to do the really big Punnett squares at the bottom of this page, and we will talk about both methods in class. So you can choose the one that works best for you. So to do it with the two smaller Punnett squares, the first thing you need are two Punnett squares. Our first trait that we're going to look at is plant height, and here we have a parent who is homozygous for tall, and we have another parent who is heterozygous for tall, and we've filled out the Punnett square already. You see we have a 50% probability of the offspring being homozygous for tall and a 50% probability of the offspring having a genotype that is heterozygous for tall, but 100% of the offspring in this cross are going to be tall. The second trait that we're going to look at is seed pod color. Both of these parents are heterozygous for seed pod color. The big Y represents yellow seed pods and the little y represents green seed pods. So 25% have the heterozygous dominant genotype, 25% have the homozygous dominant genotype, 50% have the heterozygous genotype, and 25% have the homozygous recessive genotype. So 75% of these offspring would probably have yellow seed pods, and the probability is that 25% of these offspring would have green seed pods. So now that we have the two Punnett squares, we're going to combine them and figure out the probability for a cross with these two traits. So here we have all the different possible combinations based on the offspring in the offspring boxes of the Punnett squares. So the first possibility, we have homozygous dominant everything, both seed pods and plant height. So homozygous dominant seed pod color, looking at the cross, there is a 25% chance, or 1 out of 4, or 1/4 chance that this cross would produce homozygous dominant for seed pod. And so we have we put 1/4 here. And we're going to do some multiplication, but it'll be easy multiplication. Looking at this Punnett square over here, half of them are homozygous dominant, have two capital T's. So we put 1/2 here. Then we just multiply across the top. 1 times 1 is 1. 4 times 2 is 8. And 1/8, the probability is that 1/8 of the offspring would have this genotype. So now we go to the next possibility. We have homozygous dominant for seed pod color. Again, it's 1/4. And then we have heterozygous for plant height. 50% of the offspring are heterozygous for plant height here. So we put 1/2 in this blank here. So now we have 1 times 1 is 1. 4 times 2 is 8. Same as last time, right? Now we have heterozygous for seed pod color and homozygous dominant for height. So 1/2 of the plants look like that in this Punnett square here. 1/2 of the plants look like this in this Punnett square here. So 1 times 1 is 1. 2 times 2 is 4. The probability that the plants would have that genotype from this cross is 1/4. Heterozygous for both traits. For seed pod color, 50% heterozygous. For plant height, 50% heterozygous. So it's 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. The probability is 1/4. Here we have homozygous recessive and homozygous dominant. So in this Punnett square, 25% or 1/4 of the plants are heterozygous recessive. In this Punnett square, 1/2 of the plants are not heterozygous, are homozygous recessive. Like they have the same, homo means the same. I apologize for getting the vocabulary confused when it's already confusing enough. So half of the plants in the height Punnett square are homozygous for tall. So 1 times 1 is 1. 4 times 2 is 8. The probability is 1/8. Here, for the last combination possible from this cross, we have homozygous recessive for seed pod color and heterozygous for plant height. We have 1/4 and 1/2. So 1 times 1 is 1, 4 times 2 is 8. These are our genotypic ratios. Remember, genotypic ratios, that's the ratio of the ratio probabilities, the probability ratios for these letters. The genotype is the letters. Now we have to figure out what the phenotypic ratios for this cross is. And to do that, you first figure out what the phenotypes of each one of these genotypes would be. This one, homozygous dominant for both, would have both dominant traits. This plant would be yellow and tall. This one, homozygous dominant for yellow, but heterozygous for tall. Even though it has a little t, since the big T is dominant, it's going to be tall. This plant is also yellow and tall. Here we have heterozygous for seed pod color, homozygous dominant for height, again, yellow and tall. Heterozygous for both would show both dominant traits, yellow and tall. But these two are homozygous recessive for seed pod color, so they are going to have green seed pods. So this genotype has the green tall phenotype, and this genotype also has the green tall phenotype. So you will notice that 100% of our offspring are tall, but some of them are yellow and tall, and some of them are green and tall. And to figure out what the total probability of the phenotype yellow and tall is, we have to do some addition. Now, adding these ratios is a little bit different than multiplying them. In order to add them, you need to have common denominators. That means the numbers on the bottom of the fractions have to be the same. So we are going to add 1/8 plus 1/8 plus 1/4 plus 1/4. And to do that, we're going to have to make these 1/4 into something eighths. 4 times 2 is 8, so we're just going to multiply the top and the bottom of the fraction by 2, and 1/4 becomes 2/8. So we have, oops, I went a little, okay, so we have 1/8 plus 1/8 plus 2/8 plus 2/8, which gives you 6/8, and that's not a great fraction. We want to work that down so it makes more sense. So we divide both sides by 2 and we get 3/4. There's a 3/4 chance, or 75% chance, that the offspring from this cross are going to be yellow and tall. Now let's figure the probability for the green and tall. We have 1/8 are going to be this genotype green and tall, and 1/8 are going to be this genotype green and tall. That's really easy addition. 1/8 plus 1/8 equals 2/8. 2 goes into 2 once, 2 goes into 8 four times, so we get 1/4. 3/4 plus 1/4 equals 4/4. So our fractions add up to 1 whole, and that's a way you can check your work. And we have done this cross with 2 traits for both the genotypic and phenotypic ratios. Now that was a fairly easy one because all of the offspring were tall. We're going to do a little bit more complicated one, and we're going to do it a little bit more hands-on. What if both parents were heterozygous for both traits? So what are the chances that the offspring would be homozygous dominant for both traits? If we look at this Punnett square, 1 out of the 4 are capital Y, capital Y. So we're going to put 1/4 here, and we're going to multiply that times the 1/4 in this Punnett square. You see 1/4 are capital T, capital T. So we're going to put 1/4 here. 1 times 1 is 1. 4 times 4 is 16. So our probability is 1 out of 16 that cross is going to produce offspring with this genotype. Let's move on to the next one. Again, capital Y is 1/4. And we're going to multiply that times the probability that we can be heterozygous for plant height. 2 of the boxes have capital T, lowercase t here, so the probability is 2 out of 4, or 1/2. So we're going to put 1/2 here. 1 times 1 is 1. 4 times 2 is 8, and that is the probability that this cross can produce that genotype of offspring. We're still dealing with capital Y, and the probability of that is still 1/4. And we're going to multiply that by the probability that we're going to be homozygous for the recessive trait for plant height, or short, lowercase t, lowercase t. 1 out of 4 look like that in this box, so we're going to put 1/4 here. 1 times 1 is 1. 4 times 4 is 16, so again, it's 1 out of 16. What are the chances that we're heterozygous for seed pod color and homozygous tall? The seed pod color, there are 2 of them that are heterozygous, so it's 1/2. And we're going to multiply that times 1/4 for the tall, for the homozygous tall. So 1 times 1 is 1, and 2 times 4 is 8. We get 1/8. Heterozygous for both. Here we have 1/2. Here we have 1/2. So it's going to be 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. The probability is 1/4. Here we have heterozygous for seed pod color. Again, it's 1/2. And homozygous recessive for plant height. That is 1/4. If you look at this Punnett square, 1 out of the 4 boxes are lowercase t, lowercase t. So 1/4. 1 times 1 is 1, and 2 times 4 is 8. So 1/8 is the probability for that one. Over here we have homozygous recessive for the seed pod color and homozygous dominant for plant height. 1 out of 4 look like this, and 1 out of 4 look like that. So it's 1 times 1 is 1, 4 times 4 is 16, and 1/16 is the chances for that to happen. This genotype is homozygous recessive for plant height, 1 out of 4, and that in this Punnett square look like that, times 1/2 of these are heterozygous, so it's 1/2. 1 times 1 is 1, 4 times 2 is 8, so 1/8 is the probability for that. Here we have homozygous recessive for both. 1 of 4 boxes are homozygous recessive for seed pod color. 1 out of the 4 boxes is homozygous recessive for plant height. So again, it's 1 out of 4 times 1 out of 4 is equal to 1 out of 16. So hopefully you're starting to see some patterns here, but these are our genotypic ratios. It's pretty complicated because this is a pretty complicated cross. We're going to move on and we're going to figure out our phenotypic ratios for the same cross. All you have to do is go through and figure the phenotype for each genotype, and then you got to do a little bit of easy addition over here. So we know that capital Y, capital T, that plant's going to be yellow and tall. This one, homozygous dominant for seed pod color, heterozygous for height, is also going to be yellow and tall. This one looks just like this one, except it has 2 little t's. Those 2 little t's make it homozygous recessive for plant height, so it's going to be yellow and short. This one is heterozygous for seed pod color, homozygous for plant height, homozygous dominant. It's going to have both dominant traits. Its phenotype is going to be yellow and tall. This one is heterozygous for both traits, so it's going to have the dominant trait and its phenotype for both traits, yellow and tall. Here again, we have the recessive trait for plant height, but heterozygous for seed pod color, it's going to be yellow and short. This one is homozygous recessive for seed pod color. It's going to be green, but it has the dominant trait for height, green and tall. This one is homozygous recessive for seed pod color and heterozygous for plant height. It will also be green and tall. And this one is going to be green and short because it has all recessives, and so it's going to have both of the recessive traits. Now we just have to do some simple addition, but remember, we need to have common denominators. So how many are yellow and tall? We have this one here, so that's 1 out of 16 for that one, and we're going to add it to this one here, which is 1/8. 1/8 is the same as 2/16, right? Because 8 times 2 is 16, so 2 over 16 plus here we have another yellow and tall, another 1/8, same deal, 2 out of 16 plus here we have another 1/8. This one is 1/4. So to get 16 is 4 times 4. So we need 4/16. And when we do our addition, we have 4 plus 2 plus 2 plus 1. So that is 9 out of 16. All right, let's look at the yellow and short. This one is 1 out of 16 plus yellow and short. This one is 1/8, so that's 2/16. And that is all of the yellow and shorts. So that is 2 plus 1 is 3/16. Then we have green and tall. There is 1/16 plus this one is 1/8. That is 2/16. And that gives us 3 out of 16, 3/16. Green and short, we don't even have to do any math for green and short. There's only one of these probabilities that is green and short. One of these genotypes is green and short, so 1 out of 16. And we have figured our phenotypic ratios for a dihybrid cross using the laws of probability. It's not that hard, but it's a little bit tedious. I know you can do this. Thanks for watching. Stay awesome.